Okay, adding polynomials. Okay, adding polynomials. Well, you are going to see problems like this today where they want you to add this and okay. Essentially what we're going to do is we're going to simplify, and we can really only simplify what kind of terms. What do we call these? Like terms. What makes them like? What makes them like? By the variable and to the degree of the variable. Right here I have a 5x, but I could not add that 5x to 3x squared, right? Because x and x squared aren't exactly like, okay? So this and, when we're going to be doing adding polynomials, basically is a big plus sign. We're going to put these together, and we're going to see what we have left over. So this is a positive 5x. So we're going to combine that with a positive 4x, which is going to give us, Catherine? 9x. Now here, I have a positive 3y, and what kind of a 7y? So therefore, Catherine? And there you have it. Okay. So here's what we were talking about before. We've got a negative 3x squared and a positive 6x squared. Put them together. Mark? When we had this, we added a 5x with a 4x, did we get 9x squared? No. So you're adding them together because they're like, but you're not adding these. This just tells you which ones you can add together, okay? To simplify it, to condense it, okay? Substitute the variables for whatever you want. If you wanted to say that x squared meant pizzas, fine. It doesn't matter what you want to call it, just they have to be the same for you to add them. Now, a positive 2x combined with a negative 5x, negative 3x. And finally, a regular 7 with a regular negative 3. And there it is. Okay, give it a shot. Here we go. So a 4m, I'm not going to combine with a 5p. I'm going to go with a negative 3m. It's going to leave me with what? 1m, or just m. The negative 3p and a positive 5p. Positive 2p and a 6 and a 7. Positive 13. How many have you got? Any questions? Take a look on page 152. And do you see any on there that you would like to try? What? Yeah. What's with 27? Yeah, distributed property. Busted. Okay. Negative 2 times the 4x, negative 8x, right? Okay. Negative 2 times a positive 5y is a what? Okay. And then negative 2 times a positive 7z, negative 14z. Okay. Very good. Then we move on to the x again. 3 times the 3x, 9x. Moving on to the y's. 3 times negative 3y is a negative 9y. And then moving on to the z's, should be a positive 15z, right? Okay. So a 4 plus a 5, or 4 times a 5x is a 20x. The 4 times a negative 4y is a negative 16y. And finally, the z, 4 times a 12z is a 48z. Okay? Now, it's easier for me to kind of color code them, but it might be easier to put them together that way. Negative 8 with a positive 9 puts us where, Marlia? Yeah, positive 1, right? Positive 1. Positive 1 combined with a positive 20 is a positive 21x. Negative 10 with a negative 9 is a negative 19. Negative 19 with a negative 16 is a negative 35y. And then the negative 14, positive 15, again, puts us at that positive 1. Positive 1 with a positive 48, 49z. Okay? Yes. All right, 28 through 42. They're just written vertically. So look at 28. What kind of a 2x is that? What kind of a 4x? So you combine a positive 2x with a positive 4x, you get a positive. And then you combine the positive 3 with the negative 7, and you get a negative 4. That's all it is. I don't prefer it that way either. I would rather write it out horizontally for this, but what do you do if there's a look at number 18. You have a negative a. What is it really? Negative 1a. Okay. So you're not, that doesn't bother you. 152. 2 through 26 even. Means you're up.